Hello, good evening. It's a pleasure to have all of you to this session about AI agents. The content of this session will be introduction about who we are, what we try to learn or teach. About the agents, we will present some use case, and with this some use case, we try to follow the next sections about what is an agent, what are the agents frameworks, how to evaluate these agents, and final conclusions. About me, my name is Manuel Martin. I work as a AI specialist at MDW. I've been working for the last 7 or 8 years in the AI area, more specifically natural language processing and time series areas. I think that have this background let me understand better how this new trend of generative AI models works. What about MDW? We have 3 main strategic lines that are management, artificial intelligence, and business application. We are partner of Microsoft, Databricks, Profits. We have quite relevant awards for the last years, like Partner of the Year in Switzerland and another main awards. This is the overview of our use case that we try to follow during all the session. We have in the left what are the interactions of our agent that is at this moment abstract. This is represented by this circumference and interact with the user and the Azure DevOps. And this agent manage or could be named as ticket assistant. Based on the question of the user, try to make different tasks and interact with this service, the Azure DevOps. The Azure DevOps is one of the functionalities is manage boards, backlogs, user story tasks, or in our case, tickets. The functionalities that covers this agent is chatting, information retrieval from a specific ticket, and we can create and delete tickets. With this in mind, what does this agent and what is an agent? The shortest definition of an agent, and this is quite abstract, is that autonomous system or autonomous software that operate independently from other systems. For example, is independent of the user, is independent of the Azure DevOps, and interact with both of them. Usually, and probably most of all the cases, the agents have available different tools in order to interact with this with the environment. And with all of this, we can complete several tasks. Here, the keywords are autonomous, independent, tool use, and complete task. This definition is quite abstract and probably generic. I try to use the a definition that covers many aspects and different points of view. But probably the one of the reasons is because the agent is not, the definition of agent is not a technical word in the scientific world of the AI. It's more a convenient word that most of the companies or most of the AI community use. To really understand what are the capabilities, what are the complexity requirements that we need in our use case, for example, our ticket assistant, we start to discriminate different levels of complexity of our levels. This provides a better view of what is an agent or what specific agent we are talking about. The most basic level, the level that we call basic level, is just a system that the core system is a large language model that has attached to them tools. We put three elements here, but all of them are tools. The retrieval are tools related for the information retrieval task. There are another tools that usually call memory and used to manage and handle all the historic conversation that we have when we are speaking with this system. And finally, the other tools are called here tools that are tools that are not are not retrieval or memory, that are the most typical and the basic tools that we have in our model when we start to build an agent. These tools could be execution of code, the use of databases or another web services like an API REST, etc. This basic agent, or the most basic agent level of complexity, probably all we know because are integrated in the most used platforms like ChatGPT, Cloud, or DeepSeek. This is a screenshot of the playground that has OpenAI. They were the first that used some generic or abstract word they call assistants, but it's the same like the agents. The thing here is that, as I mentioned before, we have some large language model, in this case, the GPT 4.1. We have some system instructions that usually the agents have, for example, the role. In this case is you're a SQL server, that query assistant. Your goal is to solve questions about the SQL language to the user, and we provide some guidelines. For example, in this case, I'm using the Engine SQL Server 2018. Of course, we can add some tools in order to increase the capabilities of this assistant or agent. The thing here is that this model will use in a direct way all of these tools. If we go to another platform, is in this case the Azure AI Foundry, I can show the interface. This is the main web. You can go to the agents. It's different name of assistant, but in fact it's the same. But the capabilities here that we can find here in the Azure AI Foundry, we can put any name, we can put the model, we can add the instructions like the OpenAI platform. We can add the knowledge that is equivalent that the vector search that we have in the other platform. But the difference here, and this is a more sophisticated platform or service about agents, is that we can add, for example, actions. With these actions, we can execute different tasks like write like add a new data in our database, communicate with some services, or even like I have here, connect with another agents. Of course, we can intuitively understand that this platform or these capabilities are increasing because we are integrating not just with the tools that we present before, we can connect with another agents like this. I show that because we can make a discrimination of these platforms and the levels. The next level is called workflow. Workflow is when we manually split some complex tasks into a sequence of steps. And the most typical way of see this is like a tree decision, for example, or the typical pipelines that we can find in our ETL pipelines or data pipelines. And what we do here is we have some kind of gates or prompt chaining, what we put here, and given an input we call the LLM, and we create we track the state of the situation. For example, if we are in a scenario that is the proposal of this system, we pass. In the case that doesn't this system doesn't cover this scenario, will exit. And chaining of steps, not just calls of the LLMs, also could be execution of code or update any service, etc., will go until the process finally finish. If we go back to our use case, we can review again this this process. We have several functionalities, and we will check the information retrieval from ticket. Is the most basic task that our agent can execute. The architecture of our agent system, we have the question of the user, an orchestrator agent that routes depending on of the question of the user to delegate the task to different support agents. We have an information task agent that will provide information of our issues or task or tickets, and the task creation agent. This agent will create and delete our tickets. In the other side, we will have the Azure DevOps service that will be the backend system of these tickets. If we go back to the specific task of information retrieval from ticket, if we focus on this process, what we will have is an orchestrator agent that checks if the question is related with this information retrieval task. If this situations happens, delegate or hand off this task to the information task agent. This agent will this agent have two tools available: the get a specific ticket and explore tickets. Using these tools, probably can answer the user. For example, I found your ticket, or probably similar because you have a type of error. And with the explore tickets, we can fix and adjust the 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 naming of the ID of the ticket. We can go to our demo. I have prepared this application or console application. We have some input, in this case, the user prompt. I just say hello, and the agent responds, hi, how can I assist today? We can ask about some ticket. And what we have here is the final answer. The title of our ticket is some description, the email server not responding, the status is open, critical priority, and several categories and subcategories. Here we have all the calls to the other agents. First, we call the first agent, the orchestrator agent, and these orchestrators redirect the question or use the obtain ticket agent to answer the question. In this case, this agent will use the get a specific ticket tool, and with this tool will retrieve the information to the main object. We can see better in this platform. probably we will understand better how this works. This is the orchestrator agent. We can see the internals of this is the system prompt, and as we saw, we saw before in the platform OpenAI, there is some uh, guidelines and roles that this agent has to follow. You are an agent specialized in solve ticket incidents, blah blah blah. You have different operations, casual conversation, ticket creation, etc., and you have to answer or solve the user question. This is the question I write in the console, and what the assistant generates is a tool called in order to obtain this request. This is something that our agent has available. The agent has available these tools and know how to use them. That in fact is the agent that I mentioned before answers this information. With this information, the final agent or the orchestrator agent can has all the information to answer. In this case, the agent copy and paste the same answer, but sometimes, for example, add some extra information. For example, here is the information. If you have any question, you can ask more things or some guidelines if you want to add a proper way of present the information of the ticket. The previous workflow that I present here is we can adapt our agent system to this workflow. We can put just one call to the LLM, say if are in the case of retrieve information, and if this happens, just go to the Azure DevOps and obtain the ticket information. So for the specific task of information retrieval, probably we can use this strategy of workflows. There are many other workflow topologies that we can use several of them and build more complex systems. And typical topologies that we have are redirect, in which this could be similar in our case, in which we have some model router or an LLM called router, and depending on the output, the redirection will be to another step or workflow or situation. In this case, could be perfectly our situation of retrieval information and generate the response. There are situations, for example, in which we need to parallelize the calls. The typical case is when we need to find information, we have different sources, for example, Google and Wikipedia, and we find some information. We need to execute both of them in this case. And there is another aggregator stage in which the LLM generate the final answer, trying to provide the most accurate information. There are another ways like orchestrator or evaluator. The interesting point here is that the workflows are very, as we can detect, is that all these redirections, parallelizations, and other configurations we manually has to hard coded in our system or software. Meaning that if you add, for example, a new stage, for example, the create and delete operation, you have to build all these situations that could happen when we are creating a new agent, as we can see later. So workflows, we can have a really great control in how the process will works. We can generate tests in order to evaluate the as the traditional software development. We can generate tests to evaluate if the software works successfully or not. Despite of the uncertainty of the outputs of the LLMs. Finally, we have the highest complexity that can have the agents, and we call this agent level. And in different definition that we can find in internet is the most is the only definition that we can admit as an agent. But we prefer the previous definition in which we cover several aspects and and we increase the level of this complexity. The final or the highest at this moment level of complexity that we have is that we provide some environment to the agent in which you attach to this LLM different tools. These tools helps to the model to interact with the environment, and two main tasks we can execute to this environment: an action and feedback. With this interaction with this environment, we can solve the problem of the human or the system. In fact, it's not the left side is not required that a human is the input of our agent. For that reason, when I put here the use case, the input could be not just the user, could be the Azure DevOps. We are defining our ticket assistant for the user, in which we can use for chat, information retrieval, create and delete ticket. But when, for example, a new ticket is created, if we have an open mind and vision of this ticket assistant, we can generate new workflows or new capabilities to our agent system that anytime this agent is listening the Azure DevOps, and if a new ticket is created and uploaded to our Azure DevOps, the agent, for example, could find similar tickets in order to provide a summary to the final technical support, provide a short summary or key elements in order to improve the efficiency of these technical supports. If you have another similar situations in your ticket that right now appears in your board. Here we have again the diagram that we present before. Now we will focus on the task creation. In this case, we will use the task creation agent that has two tools. One of them is communicate with the user if it's required, because the creation of this ticket follows a specific criteria protocol in order to create this ticket, and the final task to create the ticket to the Azure DevOps. This is the protocol that I've just mentioned. It's a procedure that has one customer in their internal services, and this is something that we implement in production. In this case, the ticket needs categories, and if we can follow this diagram to successfully categorize them, we have two main categories: CCS and PIL, and there are two types of categories inside them. For example, massive failure, that could be finally CSS massive, CSS no massive. In the case of PIL, if it's related with the front and back failure. In the case of front, this is the final category, but in the backend also appears here the massive and no massive. So the category here is PIL, backend massive, and category PIL, backend no massive. This is the definition. Going back to the workflows level, the medium complexity level, if we have, of course, we can build a system based on workflows that create this that creates this categorize before to create the task. Um, but we will have to create different states of, in this case, the pattern of routing each time that we have a new category or a new decision protocol. And manually, we'll have to develop all the tests and create new code and maintain all of this code. But with the main, but if we have in main the agent capabilities, we can do things like this. This workflow, this is a real case. This workflow, we can be represented like this with the merm height. It's just a diagram pseudo language that is easy to understand and of course write, because we can create new boxes and new definitions. We can create this diagram, this protocol that has its representation via this pseudo language, and we can add this definition to our code. As we can see here in this code is the similar section of the system prompt that we have in the platform of OpenAI or the Azure AI. We have, for example, you're an agent specialized to create a ticket, you will receive a user prompt, blah, blah, blah. And the most important thing, we have the guidelines like the other case. In this case, the guidelines is you need to categorize and subcategorize the ticket. And this is the workflow. I've just copy and paste from the MERMI playground or the platform that you want, and copy and paste the definition. And finally, another more requirements. It's a must. These two tags exist, and in case the category doesn't exist, return not supported. And we can create some category. As you can check, I can put here, I want to create a ticket, and in this case, each category or another properties will be asked by our agent. For example, could you provide the issue code for the ticket? You can say mail. Now starts the protocol that I mentioned before. In this case, the problem is in CSS. Yes, it's in the CSS. Is a massive or not? See? Perfect. My ticket has been successfully created with the category CSS, to category Masivo, and the issue code mail, and a new ticket ID has been generated. Perfect. Of course, the current state of the art of the models understand this diagram. But what happens if I need to add a new category? I just create a new category here. A new is called coop, and here again, the question about the massive is included here. So the main category is coop, and subcategory is massive and non-massive. The power of this is that we, with this strategy, and it's not the case of the workflow strategy, is that now we can add without implement new code, this new way of categorize our tickets of the Azure DevOps. And of course, if we try to create a ticket of cube, I doesn't change the code and the on the prompt. As we can check, I tried to create a new ticket with the name of cube, but doesn't allow me to create because tries to focus on the peel and or CSS, and that is not possible. But now we can add here this new category. And the power of this is that we doesn't modify the code. And this is implemented in our customer, a business, a non-technical developer is the person who doesn't maintain these categories. The person that maintains flow, this flow is a business person. And now we can create this new ticket with a category of cube, subcategory of Masivo. With the highest level of complexity of these agents, we can understand, even we can locate our agent in the help desk agent, this new agent ecosystem or this new paradigm. Here we have a user interface that could be the same chatbot or assistant voice, whatever, and any person of our organization or user of our services can use. There are two levels or two layers of group of agents. One of them is the domain agents. For example, here could be our orchestrator agent in our ticket assistant, but probably could be another different agents or sub agents. For example, the business to business, the finance agent, etc. And these agents are independent and autonomous from the others, doesn't share information or things like that. The second layer is the backend agent. This could be, for example, the agent that create and inspect our Azure DevOps services. And probably could be here, for example, in near from the data lakes, for example. But the help desk is, for example, for the technical support people that consult what are the state of the agents that has assigned. But could be these agents could be cross organization because, for example, another domain agents could use these agents. For example, if the help desk agent could need the requirement of this channel agent. This channel agent communicates with the mail system. In this case, for example, in the case in which our agent, this help desk agent, are listening our Azure DevOps, if a new ticket is created, we can send an email to an user in order to provide interesting information to solve the incidents. And all these backend agents are transversal also for the domain agents. And finally, the most lowest level are the backend systems, where has a one-to-one relationship with our different agents. This could be a way to understand and implement multi-agent system in our company. Of course, if our system has different services of data lakes, for example, probably will need a group of analytic agents, not just one agent. That depends of the complexity of each one. Probably our help desk agent, if we have different departments of scenarios where we are working on, maybe we need different help desk agents or a group of helpless agents. But in a short overview, this could be a starting point of having the systems. For that reason, it's quite relevant that our agents are independent and autonomous. And nowadays, uh, with all of this, we understand why the new protocols like the MCP, the agent-to-agents communication protocols are quite relevant because we are building all these agents like we saw in the Azure AI Foundry portal. We can create different agents with roles, permissions, access, etc. And what we need is just connect in an efficient way. For example, our CRM agent could be developed in TypeScript because is the way in which is the most effective way to solve this CRM agent. And the network agents are built in another platform, etc. But they need to communicate with, for example, the helpdesk agent in an efficient way and in a standard way. That's the reason why the new protocols have quite relevant today with this new paradigm. Agents, frameworks, or technologies. Mm, I put here the typical, well, the libraries that currently are the most used. We have Pydantic AI, AutoGen, LangChain, Llama Index, Crew AI, and not just frameworks. As I mentioned before, new protocols, new platforms, new services. And it's difficult to have a criteria to select the best ones for our case. This hmm, these are six questions, and probably I could provide more, but probably these are the most interesting questions that we have to answer in order to select tools, frameworks, technologies, etc. The first one is the purpose of the agent. If we are in an early stage or we are starting to use this kind of technology, probably the purpose of the agent will be or will be limited to a reduced scope. But if you have uh, a deep knowledge in all this technology, you have implemented several of them, probably your purpose of your agent requires more complex capabilities. And depending on that situation, you will have to use, for example, the OpenAI platform that is a more basic platform rather than the Azure AI Foundry that covers different complexity and probably will be the best fitted for complex scenarios. Uh, what technologies or programming language do I normally use? Some technologies or frameworks are fitted to programming language, and most relevant is technologies. If if we are using, for example, in our case that we have more expertise, if we are using the Azure AI services or all the Azure services, probably the most interesting framework could be the semantic kernel and all the stack of Azure AI Foundry agents, etc., to build our agents because probably they will have connect connectivity with all our services, a lot of connectors, mm, different paths pre-built or templates that we can use and rather than other agnostic language or frameworks that we have available in as tools. Of course, the POC, MVP, or production scope of our project is quite related with the point one. But here in this case, it's not what is the complexity of the agent, is what try to solve. Maybe I need in the case of a product of content, probably I need to evaluate the most interesting technologies, the most interesting frameworks available to my use case. And in the other side, if we're using production projects, probably I need some technologies that are in release for several months or years, rather than other technologies that are currently in preview because it's a new model released in the last week. Uh, it's compatible with other services. This is quite related with the second one. How mature is the framework uh, compared with another alternatives, and how the updates, what is the frequency of the updates of that frameworks. Well, the interesting answer here is that most of the frameworks are in an early stage of mature because this technology is quite recent. So, mm, despite of that, there are some libraries. The case, for example, one case is the case of the semantic kernel that starts 4 years or 3 years ago, rather than another's. Like, for example, here we have the OpenAI agents that has only 3 months. Of course, the frequency of the updates and how the community follows these frameworks is also a question that we have to answer and pay attention of these kind of things. If we have another projects that were successfully with the technologies or specific frameworks. Finally, oh, I have a typo. Finally, I present here the evaluation of these systems. I present some intuitions when I speak about the workflows, the second level of complexity, and I use the word test. In the workflows, we can use tests, similar tests, similar than the traditional test from the software development. But here, in the most complex situations, we use the evaluation. The evaluation have several some challenge to solve in order to understand how works our system, in order to be effective, safety, reliability, robustness, etc. With these evaluations, we're trying to validate their accuracy, identify and correct the bias, and optimize the performance. We understand better with some metrics that we have in our available or at our first approach. We have, for example, system metrics, task completion, tool interaction, and quality control. For example, uh, one one group relevant is task completion and tool interaction in order how our agent is using our tools. It's not just if this tool has a success rate. It's, for example, how many times we're using our tool. In our case of the creation or information retrieval, I put some tool that is explore the tickets. If each time that I'm asking to the user, I'm asking to the AI agent or the ticket assistant uh, for my ticket, and each time, each request I'm using these tools and the rate of this tool is 1 to 1, I have a problem because I'm given the ID of my ticket or the application it doesn't work successfully, and doesn't matter a lot the tool success rate is also how many times I'm using a specific tool that is just for backup and it's not the main tool that the AI assistant needs to use. The evaluation of the systems will provide where our system has to evolve what bias what bias has, and where we have to pay attention. The evaluation metrics is not just the input of the user, evaluate if the input of the user and the response expected, and how accurate is this answer. Because with that information, of course, has value, but has no value to identify or diagnostic or make some diagnosis on where our system uh, doesn't is working correctly. So at the end, we need granularity in these evaluations. And conclusions, agent-based systems or agentic systems solve complex problems. More complex is proportional to the levels of complexity that I presented before. And clearly, there are different alternatives, possibilities, ways of doing the same thing. But a great strategy in the planning and the execution of these systems probably will be followed by a successful project and successful execution of our tasks. Mm, Agentic solutions have high capacity to evolve and are flexible and dynamic, as we show in the demo with the diagram that we present, and anyone understand, not just a AI specialist or another technical role, can change the structure of the protocol of create a new ticket, for example, can upload this document in some store, and the new AI system can integrate in our process. Uh, this capacity is just followed by the most complex level of agents, and probably uh, the our goal is to have this in mind in order to have great results in our projects. Finally, a way to help you make some collaborations. I remember that we have three strategic lines: the data platform, artificial intelligence, business application, not just artificial intelligence. And we can help you from the defining and refining the strategy until the operations and deployment of all the any of these uh, services, platforms, or uh, projects that we have that you have in mind.